Okay, here we go with our tough section. This is 10-2, day 2. And we are going to find the area of a regular polygon. So if you remember back a chapter or two ago, a regular polygon was equilateral, all sides were congruent, and equiangular, all the interior angles were congruent. So for this, I like to just use a hexagon, but this will work for any regular polygon. So start with a decent looking regular hexagon. Okay, decent looking. So regular, all of these sides are the same. And then all of the interior angles are congruent. Now, the parts that we're going to be using in our formula, we have the center of our polygon. And when you hear the word radius, you automatically think circle. But polygons also have a radius. The radius is a segment from the center to each vertex. So if we draw those in, we are dividing this polygon up into isosceles triangles, because every one of those radius lengths are also congruent to each other. So each of these triangles is an isosceles triangle. So we are essentially going to find the area of one of these triangles and multiply by how many we have. And we have a formula for that, or we could just follow that process if we wanted. But first of all, a radius is the segment that goes from the center to a vertex. That's a radius. Now the apothem, that's pronounced apothem, is a segment from the center to the midpoint of each side. Well, if you think about it, I'll grab another color here. This apothem is essentially the height of our triangle. That'll divide that side, because it's a midpoint, and we're going to call it little a, because it's referred to as the apothem of the polygon, but it is truly the height of this one triangle. Alright, so now if you think about it, the area of this one triangle would be this distance, because it's base times height, and then times a half. Well, and I would multiply that by however many triangles I have. Well, a condensed version is to say 1/2 times that apothem multiplied by the perimeter, because that's what's going to give us our side length times however many triangles, is essentially just the perimeter. So we're not going to think of it as a single triangle times how many we have. We'll go with the book formula, which is 1/2 times the apothem times the perimeter. Okay, so sounds okay. Sometimes they don't give you everything you need, and you got to do a little bit of some trig stuff that we just learned. So I have 4 examples for us today. Some are easy, some are not. So we'll get started. So number 1, we're going to find the area of a regular heptagon with a side length of 4 feet. That's a big heptagon. Okay, so several issues here. Have to remember how many sides a heptagon has, and if you remember hepta, that was our prefix for 7. So we have 7 sides. Alright, I'm not going to bother trying. I never draw all of the sides that are here. I just do this. I like to have a picture of it, but I just kind of do the bottom of any kind of polygon and call it good. So here's what I know. My side length is 4, and I have 7 sides. I need to know the apothem and the perimeter in order for me to get area. Well, perimeter is not a problem. The perimeter, I got a side length of 4, and I know I've got 7 sides. So the perimeter is 28. The apothem is going to be a little bit of work. Oh, I know what I forgot to do up here. Dang it. I've got to come back. Come back. Here's the key. Back here, we're going to be doing some trig stuff, which means we need to know an angle. Remember, these triangles are all going to be congruent to each other. So if we think about at the center, no matter how many sides I have, if I was to add up all of the angles at the center, those would add up to 360. So if I wanted one of these angle measures, I would take 360 and divide by how many sides I had. That would tell me each of these angle measures. So I need to put that in there. It's called the central angle. I missed it in my notes. The central angle measure is 360 divided by the number of sides, because that's how many triangles I have. Okay. So, in order for us to figure out this apothem, we're going to be doing some trig. So I'm going to draw this triangle in here. What I know about the right triangle now is this bottom piece is 2, half of the 4. I need to know this angle here so that I can set up a trig problem. Well, the big angle is 360 divided by 7, because there would be 7 triangles here all the way around. So 360 divided by 7, I don't even know if that's a nice number. Oh, it's not a very nice number. But then, that's this big angle here. I want half of that because I've drawn in this apothem, cutting that angle in half. So I'm going to times this by a half, then I'll round it. So I will times by 1 divided by 2. I could have just divided by 2. 25.71. So each side of this is 25.71 degrees. So, alright, now take yourself back to SOHCAHTOA. We're going to stand here. That 2 is on the opposite side, and the one I'm trying to find, the apothem, is my adjacent side. Well, it works for me, A for adjacent, and then the hypotenuse is over here. But if you remember, SOHCAHTOA, opposite and adjacent work with tangent. So we're going to set up a tangent to find this apothem. So the tan, and I'm standing at a 25.71. Opposite is the 2. Adjacent is the apothem. I'm going to do some cross products. Hopefully you learn this trig, or you're going to be stuck in this section. So the apothem gets multiplied by the tan of 25.71. 2 gets multiplied by 1. Divide. So the apothem value is 2 divided by the tan. Oops, I hit the wrong thing. Delete. Divided by the tan of 25.71. I'm going to check my mode. Ooh, good thing I checked. I'm in radian. Okay. So the apothem is 4.15. And now we're ready for area. That was a lot of work, but we're there. To get the area, I do 1/2 times apothem times perimeter. The apothem was a whole lot of work. Perimeter we found was 28, and now it's a pretty easy problem. So 0.5 times 4.15 times 28, 58.1. They're not all going to be this much work, but they are a bit of a challenge. Okay, try another. Number 2. I've got a radius of 10. So we're going to find the area of a regular octagon with a radius equal to 10. So, again, I like pictures. Here's my center. Remember, radius is from the center to a vertex. That value is 10. In order for me to figure this out, I need perimeter and apothem. Well, I didn't give you the outside length, and I didn't give you the apothem. So we've got to do trig to get both of those. What we're going to need is this angle up here. So before I draw anything else in, let's remember that that angle is 360 divided by how many triangles I would have, and an octagon has 8 sides, so I would have 8 triangles. So 360 divided by 8 is 45. So that whole angle there is 45, but when I draw in my apothem, that's going to cut that in half. So I've got my apothem. I need to know this side length here. I'll call that x. I've got to find those two things to get perimeter and apothem. And I'm going to use trig with a half of 45 is 22.5. So I'm going to divide that by 2 and get 22.5 degrees right here where I'm going to stand. So let's go with, I can't go opposite and adjacent because those are both unknown. I have to go opposite with this or adjacent with this. So I'll do two different trig problems. Let's go with the x first. So opposite and hypotenuse, that's so that's a sine. So I'll set up sine first. So the sine, standing on 22.5, opposite is the x, over the hypotenuse is 10. I can see the x gets multiplied by 1, so I'm just going to pick up a calculator and type in 10 times the sine of 22.5. 3.83. Remember, that's from the midpoint over, so that's going to help me get my perimeter. If I double that, I will have the full side length. So I'm going to take that and times by 2. Then I'm going to times by 8 to get the full perimeter. So I'm going to keep that 3.83 times by 2. That's my side length. Times by 8. There's my perimeter. 61.23. Okay. Now I still have to find apothem, and I'll do that with trig also, and I will go with adjacent and hypotenuse this time. Adjacent and hypotenuse is ca, so I will set up a cosine standing on the 22.5. So the cosine of 22.5 equals adjacent on top, hypotenuse on the bottom. So apothem equals 10 multiplied by the cosine 22.5, 9.24, and we're ready for area. 1/2 AP, 1/2 times 9.24 times 61.23. 0.5 times 9.24 times 61.23. 282.88. How'd I do? Where are you? Oh yeah, pretty good. Okay, I think I'll save I think I'll let you practice a couple of these. I'm going to break this up into 2 days. So I'm not going to give you very many homework problems here. You might have a lot of questions, so instead of bombarding it, we'll chunk it up into 2 smaller days. So after you try these, if you don't get these, make sure you come on the Google Meet, and then I will do a couple more examples and then give you some more book problems. So I'm going to stop here on this one, and we'll do another day of this. We'll call it a day 3.